our Unit 2, Mod 6 notes on correlation and experimentation. So let's get right to it. So what is a correlational study? So a correlational study is used to see if there is a relationship between two variables. And remember, the relationship is a lot different. Saying the word relationship between two variables is a lot different than saying cause and effect. Completely different. When we are looking at a correlational study, there will be correlational coefficients. And I know that those of you that are familiar with stats know about this, so this is a little bit of review, and that will be helpful for you on tests, and maybe you can help your classmates who are less familiar. So the strongest positive correlation in mathematical terms would look like this. It would look like 1.0. That's the directly positive, and that means as one variable goes up, so does the other variable. And I'll show you what that looks like on a graph in a second. The strongest negative correlation you can have is a -1. That is the strongest. So don't be confused about, they always try to trip you up here. Don't be confused about positive being strong. Like positive and negative just mean which direction. So a negative correlation is when one variable goes up and the other one goes down. And I'll show you an example of that as well. So if there is no relationship between two variables, mathematically it would look like this, 0. If something comes up and it's 0.01 or 0.1, right? Those are going to be weaker correlations between the two variables, meaning the relationship is there, but it's really weak. So the closer you are to 1 in either direction, positive or negative, the stronger the correlation. So let's look at some scatter plots. Now, scatter plots is a vocab word in this module. I'm sure you're familiar with it, again, from math class, but just so if you're not, this is what a scatter plot looks like. So all those dots on the graph. Those are our data points, and this is a scatter plot. So we look at our line. What is the data showing us? So take a moment, pause this, and decide for yourself if this is a positive or negative correlation. Okay, so you should have paused, and how we would read this, you should learn how to read these. It could come up in a question, multiple choice. We run per week, the less we weigh. So the more we run, the less we weigh. So what is that? That is a negative correlation. So this one, it kind of gives away at the top, but why don't you pause it and try to read it? So if you were to interpret this, you would say, the more hours studied, the higher the grade. So again, pause this one and see if you can decide if it's positive or negative and how you would read it. So for this one, it is the more miles traveled, the less gasoline in the tank. So that would be a negative correlation. So pause it, practice with this one, and then I'll read it for you. So the more precipitation, the higher the cucumber yield. So positive correlation. Last one, pause it if you want to practice again. So the number of absences, as the number of absences increases, the final grade decreases. So negative. So there is also something called an illusory correlation. So this is when we perceive. Remember, our brain wants to perceive order and connections when there aren't actual connections. It's just our brain looks for that. The data does not back it up. That would be an illusory correlation. So some things that many people believe, and they're like, oh, this is common sense, right? Taking us back to Mod 4. Sugar makes children hyperactive. Well, this is an illusory correlation. There is not data to back this up. But what do people do? They see a child have birthday cake, and then the child runs around, and they say, oh, see, he's hyperactive because he just had so much sugar today at the birthday. Something called hot hand in basketball, you might be familiar with. So the idea that if someone just made a shot, we should pass it to them because they're more likely to make the next one. Because they're hot hand, right? They're hot, they're on fire. So if we take statistics, again, does not show that this to be accurate. One case of this as an example would be Larry Bird's data. He made 88% of his shots after making baskets, but 91% after missing. So an illusory correlation in hot hand. So in experiments, again, this is a review from Mod 5 a little bit, but we always need an independent variable. That is the variable that we control and manipulate. And we also need the dependent variable. So whatever we're controlling and manipulating, our independent variable, we're looking to see what effect does that have on our dependent variable. If we study more, that's our independent variable we're controlling, what effect does that have on our grades? That's the dependent variable, our grades. There are also confounding variables to things. So perhaps you do study more and your grades go up, but you hired a tutor, or maybe your grades went down and you're saying, oh, the more I study, the worse I do. But maybe that was a difficult quarter for you. Maybe there was a lot going on and you were studying more, but you weren't as focused, or you were really stressed out for that quarter. So there are confounding variables that confuse our data. So we try to limit those by using random assignment, right? When we're doing our experiment, by putting people in the either control group or the experimental group randomly. So other challenges in research, we have observer bias. If we decide that we want to observe Charlie in class because we've been told that Charlie is always out of his seat, never paying attention, and we want to get some data to back that up for mom and dad. So if we go into Charlie's classroom, we now have a motive. We are looking for data to show that Charlie is never paying attention. So anytime that Charlie's never paying attention or is not paying attention, we will take note of that and make it a data point. This alters our research, and that is not a good way to conduct research. How many times is he actually paying attention? What is the rest of the class doing? Is no one else in the class paying attention? Maybe there are other factors going on there. So in order to fix this, we use double-blind control. So double-blind control means that both the participant, Charlie, has no idea that he's being researched, and also, or what we are looking for, and the researcher, the person collecting the data, also does not know what they're looking for. They're not going in there with any agenda. They're just taking observational notes on the students in that classroom. In order for our research to be meaningful, it has to be valid. When we do a study, the results should be valid. So if they are not, so valid means testing what it is intended to test. If you give a paper and pen test to a doctor and they do excellent, amazing, their essay is great, their multiple choice is great, their diagrams, whatever, they're amazing, that doesn't necessarily mean that they're going to be an excellent doctor, right? Someone could be very knowledgeable about biology and still do poorly when they are in the operating room, right? You don't want your doctors who are, your surgeons to just do paper and pen test. So that test is not really complete or not valid in and of itself to determine what makes a good doctor. So confounding variables I just talked about, but one of these key ones that's a challenge in research is the placebo effect. So people believing something will help them and then feeling that way because they took that thing. So we use sugar pills in our control group. So let's say we have a vitamin C test. We want to try to replicate that common misconception that started from a 1970s study that vitamin C helps protect against getting sick. So we give one group, the experimental group, our vitamin C. We give the other group a sugar pill. Now, they don't know who has what. They don't know who has the sugar pill. So we can control, because some people just getting that sugar pill are like, yeah, cool, this works. Like, I got vitamin C, I definitely got it, and it's prevented me from getting colds. So we can kind of measure the two groups against each other to test for placebo effect. So again, our conditions improve without getting the real medicine. That's called the placebo effect. There's also something called the nocebo effect. This is less important, but kind of interesting. If your doctor tells you, like they legally have to tell you about side effects. I don't think they have to go into so much detail, but let's say they do. They go into a bunch of all the side effects, right? You might feel and experience those negative side effects because you heard them. So just our brains are powerful, and just by hearing that information, we might feel affected in that way. So why do we need placebos? We need to make sure that our medicine that we're using and we're saying helps people actually helps people. If a sugar pill is giving us the same results in our control group, then clearly our vitamin C is not very effective, which, by the way, vitamin C is not effective. They cannot replicate that one study conducted in 1970 to show that vitamin C helps people. But, marketing kills, and we have things like emergency, right, to help boost our immune system. And we all believe it, and maybe we experience the placebo. So there's certain triggers that make us feel like, oh, this is going to work. Like having an official bottle, having someone hand it to the sugar pill or the actual pill that doesn't do anything to us. They're wearing a lab coat and they have official labels and anything like that. So we trust and believe things just by these other circumstances that don't actually do anything. All right, so what are our takeaways from this module? Clearly, a big one for this module is that correlation does not imply causation. Cause and effect is only reserved for experiments. Our brains impact the way we see cause and effect or correlations. We are looking for patterns and connections and things that are random, or correlations that do not exist. And that's seen in illusory correlations, and we also see that in the placebo